110, 111, and 112. And our presentation topic is effect of hypertonic, isotonic, and hypotonic water speech, a biochemical perspective on osmoregulation. Our first slide is on introduction. Fish live in constant contrast with water through their gills, skin, and so the concentration of dissolved solute in the surrounding directly affects their internal biochemical environment. Water movement across physical membrane always follow osmosis, moving toward higher solute concentration until equilibrium or until opposed by active biochemical work. Osmosis osmosis and osmotic pressure. What is osmosis? The net of water molecule and osmotic pressure depend on total number of dissolved particles per gill cilia. Freely permeable via aquaporin channel, selectively permeable to ion. This selective permeability is what lets osmotic gradient be biologically acted or restricted. There are three types of tonicity, depending on the medium. First of all is isotonic. Same solute constant as fish plasma. Then hypotonic, where the lower solute concentration than plasma. And last of all, hypertonic. Here, higher solute concentration than plasma. Cellular effect, crenation and lysis. Solution. Same solute concentration as well as the same water in and out equally, stays constant. Hypertonic solution. There is higher solute concentration outside the cell. Water moves out down its gradient, causing the cell to sink and shrivel, crenation. And last, hypotonic solution, where there is concentration outside the cell. Water moves in, causing the cell to swell. If uncontrolled, it bursts, lysis. Membrane transport protein. There are various kinds of membrane transport proteins. Some of they include sodium ion, potassium ion, ATPase, then NKCC, contrasporter, CFTR, aquaporins, and carbonic anhydrase. Now, what is osmoregulation in water or ion flow? Osmoregulation is the active biochemical and physiological regulation of internal osmotic pressure, keeping body fluid solute concentration within a narrow, stable despite external osmotic challenges. Gill, skin, and gut mechanisms constitute work in water excreting or salt excreting mode to counteract passive osmosis and diffusion. The osmosis of the tonicity and osmosis of freshwater fish, isotonic medium, and marine water fish differs. Effect of ionic water. Lowest energy cost. When surrounding is isotonic to plasma, there is minimal net osmotic water flux and minimal net ionic diffusion. This is metabolically the least cost condition, which is why many euryhaline species show peak growth efficiency in near isotonic brackish water. Effect of hypotonic on freshwater fish. Water continuously diffuses in across the gill, sodium plus and chloride minus continuously diffuse out. First of all, minimal drinking, dilute urine and active ion out. If transferred to distilled or extremely dilute water, the stripper gradient can overwhelm regulatory capacity, causing plasma dilution, tissue swelling, and mortality if prolonged. Then effect of hypertonic water on marine fish. The fish continuously loses water to the environment by osmosis and gains sodium plus and chloride minus by diffusion. the opposite challenge to freshwater fish. Here they drink seawater, concentrated urine, and salt excretion. If even more concentrated water, intensified water loss and ion influx can cause dehydration, plasma hyperosmolarity, and metabolic stress if excretory capacity cannot keep pace. Now is the effect of different type of water on elasmobranch, where the strategy is different. Here, urea plus TMO is worked. Retained at high concentration in blood to raise plasma osmolarity. Shark and ray also live in hypertonic seawater, but instead of continuous drinking and active ion pumping, their liver synthesis and retain high concentration of urea and TMAO in their blood. This organic solute raises plasma osmotic concentration until it slightly exceeds water. So water diffuses naturally in the body, removing the need for constant drinking and large-scale salt pumping. TMO also counterattacks urea's tendency to destabilize protein enzyme functions. Erectile glands still exit any excess salt entering through gill and gut. Overall, are more energetically economical strategy than continuous osmotic pumping. Now, the topic is euryhaline fish. Switching environment. Species such as salmon must tolerate both hypertonic and hypotonic conditions at different life stages. In freshwater, they don't drink. Gill ionocyte actively absorb sodium and chloride from dilute water. Kidney produce large volume of dilute urine. In seawater, rising cortisol IGF-1 gill chlorophyll boost sodium and potassium plus ion ATPase and NKCC. Then gill switches from salt uptake to salt excretion. Fish drink seawater, kidney shift to small concentrated isoosmotic urine. Hormonal regulation of osmoregulation. Cortisol. Increase the number and activity of gill chloride cell and stimulate sodium plus potassium plus ATPase synthesis, key for seawater acclimation and smoltification. Prolactin. Promote freshwater adaptation by reducing gill permeability to water and ion and enhancing ion update. The freshwater adapting hormone. Growth hormone or IGF-1 work with cortisol to enhance seawater tolerance by upregulating gill sodium plus potassium plus ATPase expression. Arginine vasopressin influences kidney water permeability and urine output analogous to vasopressin in mammals. Now it is a comparative summary difference between freshwater versus marine water. First feature is osmotic problem. In freshwater, water enters by osmosis, salt lost by diffusion. Marine water, water lost by osmosis, salt diffuse in. Drinking behavior. Freshwater fish does not drink, or if drink, it is very little in amount. And marine water drinks large amount continuously. Urine output. In freshwater fish, large volume and dilute. And in marine water fish, small volume concentrated. Gill ionocyte function. In freshwater fish, it actively uptake of sodium plus and chloride minus. But in marine water fish, active excretion of excess sodium and chloride ion. Kidney role. Freshwater fish mainly large glomeruli, and in marine water fish, few small or agglomerular. In freshwater fish, nitrogen excretion mainly ammonia gills, but in marine water fish, ammonia plus some via guts. In freshwater fish, extrarenal salt excretion not required, but in marine water fish, it is needed. Conclusion. The tonicity of surrounding water, hypertonic, isotonic, or hydrosgenic skin and gut membrane. Because fish cannot allow their internal osmotic environment to drift far from its set point, biochemical mechanisms act around sodium and potassium ASA, ion channel, and hormonally controlled gene expression must continuously to active work to oppose this passive physical gradient. Hypertonic water demand the least biochemical effort, while hypertonic and hypotonic extremes each were this energetically costly adaptations, illustrating how osmosis and membrane transport underlie fish survival and distribution across freshwater, brackish, and marine water habitat. Uh, our slide is thank you, sir, and everyone for giving me the chance.
ব্রাকিশ শব্দের অর্থ কি?
স্যার ব্রাকিশ ওয়াটার হচ্ছে যেখানে সল্ট ওয়াটার আর মেরিন ওয়াটার দুইটা মেরিন ওয়াটার ফ্রেশ ওয়াটার দুইটা মিক্স হয়। এখানে থাকে 0.5 থেকে 33 ppt।
তুমি উদাহরণ দিচ্ছ, কোন মাছের উদাহরণ দিচ্ছ? তুমি উদাহরণ দিবা ইলিশ, ইলিশ বাদ দিয়ে তুমি উদাহরণ দিচ্ছ বিদেশি মাছ। যাও তুমি দুইটা থেকে আগে যাও।
জি স্যার।
ইলিশের কোন উদাহরণ তুমি পাও নাই?
স্যার ইলিশ ও ব্রাকিশ ওয়াটার ফিশ।
না, তুমি যে উদাহরণের আগে যে দিচ্ছ তুমি দুইটা থেকে আগে যাও। দুইটা স্লাইড আগে যাও।
জি স্যার।
কই গেছো? দুইটা স্লাইড আগে, আরো আগে যাও। এই যে সালমান মাছের তুমি উদাহরণ দিচ্ছ, তাই না?
জি স্যার।
সালমান মাছ উদাহরণ না দিয়ে তুমি তো ইলিশের উদাহরণ দিতে পারতা না?
জি স্যার।
ইলিশও তো, সালমন মাছও যেমন ম্যাগেটিং ফিশ, ইলিশও সেরকম ম্যাগেটিং ফিশ। ঠিক আছে, তুমি তো ইন্টারনেট থেকে তথ্য সার্চ করছো। তুমি যে এই ধরনের এই যে অসমো রেগুলেশন নিয়ে আমাদের ইউনিভার্সিটিতে গবেষণা করে কে এই ফিশ নিয়ে, জানো?
স্যার সরি।
না জানলে হবে কি?
স্যার
এই
আমি
সমস্ত
চেষ্টা করবো জেনে নিতে।
তোমরা সবাই দেখা যাচ্ছে যে দূর দূরান্তের ই নিয়ে তোমরা গবেষণা করো, কিন্তু ওই যে কাছের ই নিয়ে তোমরা কি করো না, গবেষণা করো না। এই জিনিসগুলো তোমাদেরকে কি করতে হবে, জানতে